This is Josh White with JW Math Tutoring. In this video, I'm going to go through Bluebook Practice Test 9, the Math section, Module 2A, the easier of the 2 second math modules. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before I get started on this Bluebook Digital SAT Practice Test 9, Math section, Module 2A, the easier of the 2 second modules, please keep the following things in mind. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, this video will most likely not run past the allotted time, but if it would, or if you watch my other videos that do, just keep in mind that the reason for that is because I'm showing multiple ways to solve some of the problems. So I might show 3 or even 4 different methods to solve the problems. But on an official test, of course, you would not have to, solve it using all those ways. You would only have to solve it one way and maybe use a second method to check it. And third, if you haven't done so already, please do check out the videos to this same Practice Test 9 Module 1 and also Practice Test 9 Module 2B, the harder of the 2 second math modules. So with that said, let's go ahead and get started on, again, this digital SAT Practice Test 9 in the Bluebook app. Math section Module 2A was just released about 2.5 weeks ago. All right, so this first question here, we just have a basic linear equation. What's the solution? Well, we just subtract 12 on both sides, and that's going to give us 324 as the value for k. So the correct answer is B. And also, just a reminder, you can go into Desmos and you can type in the equation as it's written, except you can't use k. You have to change the k to x if you want to use this method. Now you're going to have to zoom out a ways. There's the line eventually right here, 324. However, I will tell you, if you do want to use k, what you do is you just use regression. So you just type it like this, and then it tells you right there, k is 324. So if you ever have these equations and they have letters other than x, just use regression, and you can keep the letter as it is. All right, question number 2. We're just converting 51 meters to centimeters, and they give us the conversion factor here, which is 1 meter is 100 centimeters. So meters will cancel, and then we just multiply 51 times 100, so we just get 5,100 centimeters. Correct answer is C. Don't need to do anything else. All right, next up, you have a system of linear equations and it's graphed. So what is the solution? Well, it's just this intersection point right here at 2, 2. Correct answer is letter B. We can move on to the next question. Number 4, you have a graph of an exponential function. What is the y-intercept on this graph? Well, it's just this point right here. And the y-coordinate for that is 3. So the correct answer for this is just 3, and we can move on to the next problem. Number 5, we have a bar graph. This question wants to know how many more students are in drama than in chess. So notice the number in drama is going to be 40. The number in chess is going to be 30. So how many more is that? Well, just subtract them. 40 minus 30, you get 10. The answer is letter A, and we can move on to the next question. All right, next up, question number 6. So this one, there are multiple ways you can do it. What I would say the traditional way to solve this is take the top and basically factor it, continue factoring it by pulling out a common factor of x minus 7. And then what you're left with is going to be 8x minus 3. On the bottom, you pull out a common factor of 2, and then you are left within the parentheses x minus 7. Now, you cancel out the x minus 7s, so correct answer 8x minus 3 over 2. All right, so again, that's the traditional way to solve it. Of course, though, we could go to Desmos, and we can do the following. We can type the original problem, and then we're going to compare that graph, which is actually, it's really just going to end up being a line, to the answer choices. So let's do x minus 7 over 5. Answer choice A. Are they the same? No. Let's do the next one. 8x minus 3 over 2. Are they the same? Yes. Notice they overlap completely. That tells me that the expressions are equivalent. You can try C and D. I'm not going to spend time doing them here, but just so you know, if you type them in, you will see that they do not match the original expression in the problem. Next up, simple percentages question. 80% of 300. In other words, 0.80 times 300. The correct answer for this is 240. And again, you can go to Desmos with percentages and you can just basically type it in, as I said it. You can say 80% of 300, and there's your answer right there, 240. And that's it. Next up, number 8. Here we have basically you could look at it as a unit conversion problem. You could look at it as a rate times distance problem. Essentially, what we're doing here is we have his speed of 4 kilometers per hour, and we want to know how many hours he must walk in order to satisfy, uh, that goal. So if you think about it, so one way to think about this is it's like rate times time equals distance, right? The rate is 4, time we don't know, distance is 24. So you just plug those in, divide it, you get time equals 6 hours. So the correct answer here is letter B. Now, another way that you could set this up, and you're going to see it's basically going to essentially be the same thing. It's just a different way of thinking about it or approaching it, is you can treat it like a unit conversion problem where you're like, okay, 4 kilometers per hour times X hours is going to equal 24 kilometers. So the hours cancel out. I get kilometers on both sides. And now you just end up with the same equation that I had before, 4x equals 24, 6 hours. It's just this is a slightly different way of thinking about it or approaching it rather than just, rather than having the rate times time equals distance equation memorized. So whichever approach you take, it's just going to be 6 hours. And of course, you could also just back solve this. You could say, okay, well, if it's 4 kilometers per hour, you just go through the answer choices and see which one will give how many number of hours would give me 24. And well, it's going to be 4 times 6. So you could also think of it that way as well. Next up, we have question number 9. Let's see if I can zoom out here to get all the values on the screen. Which are the corresponding values for this problem? So if you're going to do this the traditional way, meaning not using Desmos, what I would do is I would start with 0 and I'd plug that in. And I get 0 plus 4 equals 4. So 0, 4 is a point we're looking for. So yes, no, no, no. Oh, looks like we have our correct answer right away. It has to be letter A. And you didn't even actually need to do that. You should be able to look at this equation and realize, oh, the y-intercept value is 4, therefore I would expect to see 0, 4. In other words, I didn't even need to plug 0 in. You should just be able to recognize that's the y-intercept. Now, if you're going to go do this in Desmos, there's multiple ways you could do this. So one way to do it would be to graph it, and then you go up here and you click this, and then notice it auto-generates a table. And you can just easily see right here 041526. And you just look at it. Oh, that obviously matches answer choice A. Okay. Or you could just, again, you could graph the line and then you could start with A and you could like plot the points individually and you could see, are they on it? Yes, yes, yes. Okay, that has to be the correct answer. Whereas if you were plotting out like answer choice B, you would see, okay, that point's not on it. That point is 2, 4, that's not on it. Therefore, that's wrong. So that's another approach you could take in Desmos as well. All right, next up, question number 10. Let me just snap back to the default view. Control plus 0, by the way, if you ever zoom in or zoom out. Control and 0 will get you back to the default zoom level. Here you have a function. For what value this function is this function equal to 54? So it's just 6x equals 54. We're replacing g of x with 54. X is going to be 9, dividing both sides by 6. So that's our correct answer. Of course, if you go to Desmos, you could just do it multiple ways. You could just type 54 equals 6x and look for the vertical line. Or you could also say y equals 54, y equals 6x, basically y equals left side, y equals right side, and just look for the intersection. And it's right here where the x coordinate is 9. Next up, question number 11. Basically interpreting this text into an equation for renting a tent at a cost of $11 per day plus a one-time fee. Okay, so there's a one-time fee of $10, and then it's $11 per day. So that needs to be multiplied by D days to get your total cost. And then that's just going to equal C. So which equation does this match? So the first one is equivalent to 11D plus 110 if you multiply it out. That is not correct. Second one is 10D plus, looks like the same thing, 110. That is not correct. 11D plus 10, C is correct. Even though the terms are switched, that's fine because addition is commutative. So C is the correct answer. And then D, notice again, it has the wrong number in front of D and the wrong, basically, y-intercept. Also briefly mention, you could also do this one using back solving. What you would say is like, say I rent the tent for 2 days, okay? That's $11 plus, sorry, it's 11 times 2 plus 10. 22 plus 10, 32. And then you'd go through all these answer choices, you'd plug in 2 for D, and you'd see which one equals 32. Okay, and it's going to be letter C. That's the only one that's going to equal 32 and give you the correct answer. All right, next up is question number 12. All right, so here we have two parallel lines. And the fact that they're parallel actually does not matter into this problem at all because these two angles here, x degrees and 142 degrees, are just two adjacent angles that form a straight line, basically form a straight angle. Therefore, they add up to 180 degrees. The correct answer is D. These are basically what's also known as a linear pair. So we can move on to the next problem. All right, for number 13 now, you are given the width and length of a rectangle, and we just want to know the area. So of course, area is length times width. So I guess technically I would put 34 first because that's the length and 29 second, although it doesn't matter because again, multiplication is commutative as well. So what is 34 times 29? Well, it's just 986, and that is our correct answer. And we can move on to the next problem. All right, number 14. Here you have a problem where you're given the equation of a line and they tell you that h of 0 equals 45. What's the value of b? So the answer is just 45. You should recognize that h of 0 equals 45 means that this line goes through the point 0, comma 45, which is the y-intercept. The y-intercept is always 0, comma b. Therefore, b equals 45. However, if you didn't recognize that, you can always just go to Desmos as a backup, make a table. You got to know to put in 0, 45, and then do your linear regression. Y1 equals x1 plus b. And then it'll tell you right here, b is 45, and we have our answer. Next question, number 15. Here you have a line that goes through a given point, and it's parallel to this other given line. So first we need to notice that this given line has a slope of 7. Parallel lines have the same slope. Therefore, the slope of our line will also have a slope of 7. So right off the bat, you know this is wrong, has a slope of 5. This is wrong, has a slope of 5. We need a slope of 7. Also, you're told it goes through the point 0, comma 5. Therefore, I know that that is the y-intercept value. So the correct answer for this is going to be letter B. But again, you could go back to Desmos here, and you could put in the point 0, 5. And then for your regression, you would do, y1 tilde, and then 7x1 plus b. And then again, it just gives you b is equal to 5. And that would confirm, again, correct answer is letter B. Let's look at number 16 next now. We have a linear inequality in two variables. It's graphed. There's shading, obviously. Which point is the solution to this? So you should be able to just kind of like look at the graph and see which of these is in the shaded region. So -5, -6, right here. Is that in the shading? Nope. -2, 5. That's right here. Is that in the shading? Nope. 1, 4. Is that in the shading? No, it is not. What about 6, -2? Yes. Therefore, the correct answer for this problem is going to be letter D. Okay, next up, an exponential function uh, is what this problem is dealing with. Talk about number of bacteria that's doubling. So there are 44,000 bacteria to start. That means the initial value in front has to be 44,000. So right off the bat, these two are out. You need a 44,000 right here in the front. And the fact that it's doubling means that the base, it's being raised to your variable, to your exponent, is going to be 2. Doubling means multiplying by 2. So the correct answer for this one is going to be letter D. Basically, C is what the equation would be if it was halving, if it was decreasing, by 1/2 over each time period. Basically, looks like over a day. Next up, number 18. Here we have a question where we have, let's see, the product of a number and 8 more than the number. So 8 more than x is just x plus 8 or 8 plus x, however you want to write it. And that's equal to 180. So if you're going to solve this by hand, you could just go ahead and distribute this out, and then I would just subtract 180 over. Then I would probably factor this. So I'd say, okay, what are the factors of 180 that negative 180 that add to give positive 8. It's going to be, it looks like plus 18 minus 10. So plus 18 minus 10. So x equals 10 or x equals negative 18. So which of these do we see up here? Well, I see positive 10 in letter B. So that is the correct answer. Now, I will tell you, once you get the equation, of course, you could just go to Desmos. So once you set it up, but you still have to get the actual equation. And now let's just zoom out where our answers. Okay, positive 10 is 1, negative 18 is 1. That's what we got solving it by hand. So you could do the actual solving process, like I said, in Desmos. All right, question number 19. What is a solution to this given equation? So it's already factored, so we can just take each factor and set it equal to 0. Minus 4, 5x equals negative 4, x equals negative 4/5. Add 5. We actually don't even need to do this because all the answers are negative, so this really doesn't matter. On the actual test, you probably just don't waste time doing this. But we get negative 4/5 and positive 5/2. Okay, negative 4/5 right here. It looks like the correct answer for this one is going to be letter. Next up, question number 20. Interpretation of a linear function type problem. So what does 5y stand for? So notice 32, okay, is a total number of cups. So that means the two things that are added on the left also have to be a total number of cups because you have to add cups plus cups to get cups. So 5y is a number of cups. Therefore, A and B are out. So is it the cups that are in large jars or small jars? So right here it tells us that y represents the number of large jars. Therefore, the correct answer for this problem has to be letter C, number of cups of broth in the large jars. All right, for number 21, they want to know which of these expressions represents the length of this cutting board. They tell you the area is equal to W times W plus 9. And they also tell you that just this W here is equal to the width. So we know area is equal to length times width, or you could switch it and you could make it width times length because multiplication is commutative. Therefore, the length must equal W plus 9, the other expression that's being multiplied in this problem. So the correct answer for this is just going to be letter D. Next up, we have question number 22, the last one on this module 2A from practice test 9. You're given two angles in radians. You are then told to find, actually, sorry, you're given one angle in radians and you're given a difference between the given angle and another angle, and you want to find the measure of the other angle. So, in other words, we have 2 pi over 3 radians. This angle t is 5 pi over 12 greater than it. So we want to take that and increase it by 5 pi over 12. So let's just multiply it by 4 to get a common denominator. That's going to give us 8 pi over 12 plus 5 pi over 12. Okay, that's 13 pi over 12. The problem is these answers are all in degrees. So now you have to convert this to degrees, and the conversion factor is, again, this is radians, so you have radians on top. So you need it with the radians on the bottom and degrees on the top. Pi radians, 180 degrees. So radians cancel out, pi cancels out. Technically 12 goes into 180 15 times, but you could just do this whole thing in Desmos. And then 13 times 15 is going to be 195 degrees. The correct answer is going to be letter C. Now, just to show you a couple things. So you have 2 pi over 3, and you add to it 5 pi over 12. So you get this value, right? Okay, so now I'm going to just store this as like t, because this is the measure of angle t. And now what I'm going to do is I'm going to take t and I'm going to multiply it by 180 over pi. And notice now it nicely basically converts it back into 195 degrees. Like the fact that for t, when you do it in Desmos, the fact that the number of radians was not a nice fraction, that was not like 13 pi over 12, it was just this 3.403, but that doesn't matter, because if you carry along the exact value, and that's why I define this to be t, then when you multiply it by 180 over pi, that will give you, the 195 that you're looking for. All right, so hope you enjoyed this video on Digital SAT Practice Test 9, Math Section Module 2A, the easier of the 2-second modules. If you have any questions or comments on any of the problems discussed here, please do leave them below. Otherwise, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, check out the solutions to Practice Test 9 Module 1 and Practice Test 9 Module 2B, the harder of the 2-second modules, if you haven't done so already. And lastly, if you're looking to improve your Desmos skills, please do check out my Ultimate Desmos Guide to Digital SAT Math, over 3.5 hours of all kinds of Desmos tips and tricks and example problems for you to learn and practice with.